Now, Science 1, first topic, gravitation, we will start today. All of you know, force is a very important on the earth. With the help of force, we can throw any object, we can pick up any object, we can change the direction of an object. Means force is a very necessary for moving, pushing and changing the direction of an object. There are various types of forces present on the earth. For example, muscular force, magnetic force, mechanical force, and lastly, important force is a gravitational force. So, who found the gravitation on the earth? Gravitational force is a present on the earth is discovered by one of the famous scientists, Sir Isaac Newton. He concluded that there is a presence of gravitational force on the center of earth, and because of that, every object when we fall from any height, it can falls on the earth. Suppose Newton observed one plant. Suppose here is a surface. Apple. He observed that one apple tree here and one apple falls vertically on the surface of earth. It does not go horizontally or any other direction. By observing this phenomenon, he concluded that there is something present in the center of earth, and that force which is present due to which apple attracts toward the earth, he named as a gravitational force. Not only apple and earth, every object which are present on the earth having attraction between the two objects. Suppose if I saw if I taken two objects, then in between the two objects there is a little bit force is present. So what is mean by gravitation? The property of attraction in the universe. The property of attraction in the universe is called as a gravitation. Now, which force is present on the earth? That is the gravitational force. And because of this gravitational force, we are moving here and there. We are moving here and there, as well as every movement occurs smoothly on the earth because of this force. Now, next point, I will explain first Newton's laws. Newton discovered 3 laws. According to first law of Newton, every object becomes at a rest position or in a uniform motion until the external force cannot apply on that object. Now the second is the acceleration. The second law of the Newton is the acceleration of any object depends on the force and mass. And third law of Newton explains that for every action there is a equal and opposite reaction. Now, according to Newton, he explained 3 laws, and now the next point he explained that gravitational constant. Gravitational force. All of you know, force is equal to mass into acceleration. Suppose we will take two bodies, two objects having the mass m1 and m2. These are the two objects or two bodies. In between, from the center, the distance is d. Here is a one object having mass m1, next object having mass m2, and the distance between the two objects is a d. Then how we will write it is? F is directly proportional to m1 m2 divided by d square. Means what is meant by directional proportional? Force, if force is increased, mass, the product of m1 and m2 will be increased. If it is decreased, then it will be decreased. Means it is a directly proportional. And F is inversely proportional to the square of distance between them. Inversely means what? If one is increased, other will be decreased. So here we will say that force is proportional, directly proportional to the product of the masses of the two objects, and it is inversely proportional to the square of distance between two objects. Now if we want to remove this sign, then how we will write? F is equal to G m1 m2 divided by d square. So what is mean by G? G means gravitational constant. Why it is called as a constant? Because on everywhere on the earth, gravitational value is a constant. Suppose I want to remove the unit of the G, then what I will do? F, this D, here d square divided by m1 into m2 is equal to G. All of you understood? See, I kept here G. This d square comes on upper side and this on the denominator side. Then we will feel the value that, suppose, what is the unit of the force is Newton. Unit of the force is Newton. I am writing shortly here. Now, d square means distance. What is the unit of distance? Is meter. Here is a meter square. So, I am writing here meter square. Now, m1, m2 means it is a product of the masses. Mass we will calculate in a kilogram. So, kg into kg. Here is a kg square. The unit of G, SI unit of the gravitational constant is Newton meter square per kg square. If we take on the numerator, means upper side, then how we will write here? Newton meter square kg minus 2. This is the unit of gravitation, SI unit of the gravitation or G. Now here the value of G is a constant 6.673 into 10 raised to minus 11 Newton meter square kilogram per minus 2. Means, again we will read this. Gravitation value is 6.673 into 10 raised to minus 11 Newton meter square kg minus 2. So here we finish gravitational force, and unit of the gravitational force is this one. Now next point we will start Kepler's laws.